Welcome, I'm Bill Wake. We're here working on a program to compare tunes for similarity, and we're to the point of making what they call dendrograms to show the connections between clusters that we've identified. All right, we left off with an error. Let's see, I think it's in here. And I had a theory yesterday for what was going on, and we'll see if that's right. But basically, a cluster has two children. We're getting the first one right and the second one wrong as far as the placement. And I'm pretty sure it's to do with the starting point of this thing. So let's see if we can get the example. So here we have 1 and 2 are clustered together, 7 and 8, and then a big cluster overall, both the subclusters. Okay, so I expect if this is slot 0, slot 1, I expect the center line for the first cluster here to be halfway, 0.5, halfway between them. And this is 2 and 3, I expect it to be 2.5. And then this one should be halfway between 0.5 and 2.5, I think. 1.5? We're getting 1.5. All right. Let me check this again. Oh yeah, this is connector 6. I expect to be 2.5, and it's only 1.5. The center should be of all of them should be 1.5. Okay, and let's see the place this is happening. It's in this connections method. Yeah, connectors method. Keep calling it connections. All right. And what I think is going on, well, yeah, what I think is going on, I think it comes down to the starting row. Okay, so normally we're passed in like what's your starting row, so we can count 0, 1, 2, 3, 4. The first one starts at starting row, and then the second one, well, it's got to reflect the number of elements in the first one, but it also has to do starting row plus. Now, I think what I did yesterday, was did this, which is half the change. We get a bunch of failures. Like, okay, something's funny. I'm glad that passed, but I don't think that's quite the whole story, because these should need the same treatment, I think. So why is that not failing? Okay, let's make sure the numbers are right in here. Okay, so 0.5, 2.5, 1.5. I'm glad those are okay. But the connectors... Gosh, I sure thought that should be there too. Let me see if that changes anything. I run all tests. I'm not sure I did just now. Okay, and let me do this again. Okay, how do I reveal this problem? So the connectors, oh, okay. The problem is starting row is 0 in this simple test. Here, well, we call connectors, which is sort of an entry point into slot 0. And so starting row plus is also 0 on this connectors.count. I think I would have to set up, let me try setting up a more complicated case. Let's take that back out. Okay, it's out. what if we do a more complicated case? Let's put let's put another cluster in. Okay, whoops. These three. Okay, E3, E4, E5, E6. I'm going to cluster 7, 8, 9, 10. I guess 10 and 11. Okay, so these two cluster really closely. This one should, that cluster's there. This one, let's make 7, clusters these two with high probability. Okay, so element 7 says these two cluster. Now, I think we want to make C2 and C3 cluster. Cluster, call this 8. 0.875. C2, C3, and now C5, sequence number 9. Let's make it, I think 925. I'm trying to pick numbers that come out even in binary. C1 and C4. Okay, so I'm clustering these two somewhat, these two, and then I'm saying, well, these two are really pretty close to each other, so their cluster 8 is C4, and the last bit, C1, we're going to pick up with C4. Okay, and now what are we getting? Well, there's a lot of we got 6 elements now. Wait a minute. 1, 2, 3, 4. There should be 5, 6, 5, 6. The numbers really don't matter, but they have to be consistent. 7, 8, 9, 10, 11. Okay. 1 and 2 clustered together in 7. 3, 7 and 8 clustered together. 10 and 11 clustered together. The last 2 clusters together, and then the final thing. Okay, so there are, how many connectors are there? Well, there's 1, 2, 3, 4, 5. Okay, I don't know. Let's make this one 1.0. All right. Well, my prediction is I will blow up even if I don't catch things right. Okay, cluster 1, C1 is ID 7. Level 0.75, top line, bottom line. Yeah, I think that's correct. Then number 1 is number 8.75. That shall be the same. 2.5, that's believable. Okay, then number 3, 9. I'm not sure about the level. I think that's a 0.75. And then these lines should all be 0.75. And I believe the center is going to be 4.5 because he's 2 rows down. Okay, now actual 4. I'm not going to bother computing this. Just going to get the names right. 10, actual 5, and 11. I think it's going to blow up, so I'm more worried about that. This is C5. Okay. If it doesn't blow up, I'll put my guesses in. Okay. Yeah. ID 11 2. Let's make sure actual.count is 5. How about 0, 1, 2, 3, 4? Let's try that again. Okay. 2.5 is not equal to 4.5. Okay, yeah, so now we've got the second one. We came in with this one as the first one, and this one, the second one. Now, this one has a different, his starting row is not 0. It's 0, 1, 2, 3, 4 for this. Okay, so I will feel better about this. Okay, and like I said, the numbers, the distance numbers probably will be wrong, because I didn't work out what 4 and 5 should be, or the last two. Center 3.5. Yes, that's correct. Because he's connecting 2.5 to 4.5, so halfway between is 3.5. Levels 875. That comes from here. So I think this level should be 1. Okay. These should be shorter. 1, 2, 5. Okay, and then this one, center 2. So it's connecting 3.5 and 0.5. I don't know if that's quite where I expected. 0.25. 125. Okay. The center of 3.5. All right. Let's see. I gotta get these straight in my head. Which is which? Okay. So those are the first 3 connectors. Then we connect the bottom 2 clusters. And their center is 3.5, right? And then the top one connects 0.5 to 3.5. I would have thought that'd be 1.5, but I think it's coming up 2. Now, is that right? Center 2. Okay, well, we're going to look at this one. All right, let's look at what we have. I think this should be looking good. Yeah, that's okay. Let's put this more complicated cluster in there. Dendrogram view. take that out. We'll let C5 be the one we care about. This stuff we'll comment out. Okay, so I'm just creating this example cluster. Oh, is this one character? Yeah, okay, let's make this back into it. We just changed it to prove we could do it before. We're going to eventually put tunes in there or something like that, tune numbers. Okay, stage elements. All right, let's run. Oh, something's weird. Well, I think, I'm not sure everything that's going on here, but 1 and 2, I mean, we definitely have a problem because these last two nodes are not here, 9 and 10. Okay, so why is that? Sorry, 10 and 11. We got 1, 2, 7, 8. And then no 10, 11. Okay, let's see if we can figure out that. Okay. The other thing is, I don't know that we're drawing our stuff. I'm not convinced we're drawing everything properly vertically. I think all the horizontal links should be right, and they look kind of right to me. But yeah, there's something funny. All right. I guess what I want to see is, like, first thing is, where are these? To lose a higher. Well, I think our test was that. Let's see. Is this test? Well, this is 3. Yeah, we can put a more intermediate test. Oh, 1.5. I think we. Sorry, let me run these tests. I'm not sure we ran them that last time. Okay. E5 never used. That's a bad sign. Okay, I guess it would help if I set up the situation. I thought I was. 6. Well, then I'm going to go back to. Yeah, we have that one. This is. Well, we have the 2 leaves. The cluster composed of 1 leaf. So a cluster. Yeah, that's this case. So 1 and 2 are a cluster, and 3. I guess we could swap the order. I really had hopes that this would be right, honestly. So. And the reason for this test was, I'm not sure you were quite here, but this, I had put just this one starting row plus. It really belongs in both places because they're both working from the same place. Whether that seems suspicious to me in a way, but I think they both need to be consistent at least. And so that test was designed to be complicated enough to trigger the lack of this causing a problem. But I'm most, okay, E5, E6. Yeah, wait a minute. So I didn't have those in my cluster, so no wonder I only got 4 nodes drawn. Okay, so that I can see now. E5, E6. That should change something here. This last number I think is suspicious too. Okay, so halfway between here and here is 3. Connecting 3 to 0.5, I would expect it to be like 1.25. Not 2. Okay. Let's fix the dendrogram. E5. E6. Okay. Okay, well, it's slightly better. At least all the values are here. This is suspicious. Now, these lines are definitely suspicious to me. I don't know if we still have our prints. That may be just too much to make sense of. 2020 to 8090, 2020 to 8090, same one twice. It's very suspicious. 2020 to 2036. Yeah, it's like we're not moving down vertically. Okay, so let's see what you're suggesting here. Cluster with 2 nodes. Okay, I think we could flip this cluster. Let's leave the view part for now. I'm gonna flip this case. Okay, so this has 1 and 2 clustered and then adds 3. Let's start with 1 and add 2 and 3. Okay, so I don't like that test name. It's not a deep cluster. It's maybe 2 clusters. And then flipped. Okay, C1, 2, 3, C4. Let's make this C2, C3. I'll make it 0.5. And then C5 is, let's do in order, C1, C3. Sorry, C4. Okay, so this is 0, 1, 2. The connector for C4 connects 2 to 3, so 1 to 2 should be 1.5. And level is 0.5. Top line is 0.5, and bottom line is 0.5. Okay, then we expect this cluster. Okay, so 0.75. So I think the top line should be 0.75. The bottom line is going to be 0.75 minus 0.5, so 0.25. And then this is centered at 1.5. Sorry, yeah, the center line here is 1.5 and 0, so 0.75. I should be using the center values to calculate the cluster centers. I think we are at this point. We're saying a given node, its center is the center of the 2 child nodes. Does that seem like what we're doing here or no? I know I get tangled in my mind on all this stuff. All right. Okay, so let's take this test and talk myself through it again. So line 0, line 1, line 2. Let's maybe just make those consistent with that. Okay, 0, 1, and 2. All right, cluster 4 is C2 and C3. So 1 and 2 should be 1.5. And it needs the full length of 0.5 to get there. Then this cluster should connect 1.5, the center of these two, to 0, the center of this element. So 1.5 over 2 is 3/4. So that's that center. The top line connects all the way across because we didn't do it, and the bottom line connects that. Okay. I hope this test passes, but if it doesn't, that'd be plenty interesting. Okay. What did they do? Top line. Level 0.875. Oh, that can't be right. It should be the level of this. Was the other stuff right? Top line 7.5, bottom line 2.5, center 0.75. Okay, I think that one's okay. 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 Let's take a look at this one. I don't know. I definitely bounce around on these a little bit too much with this. It's such a visual thing. I think it's easy to convince myself the numbers are right and they're not drawing right, and that's a problem. Okay, so I'll comment these out. Okay.
Don't do that to my books. No. Damn it. You don't do that to my books, honey. I don't like it.
Okay, cluster. Okay. I think maybe we're drawing funny. I think, I don't know. These two, I think these two should have gotten these two lines. The two horizontal ones here should have been from there to there, and then this one should have been on top. Okay, so I think that's our drawing stuff. We didn't have the centers before and the line order and stuff, so I don't know if it's that. Well, gosh, that's. See, that number, that just seems wrong to me. Why does the number come into it? Right? Given a connector, let's go into shape. Okay. Connector bottom line. Okay, that vertical line, right? That third line. Y scale. That's not quite right. It should be like Y scale times connector dot center, or what do we call that? The center, gosh, I don't know. Well, I don't trust this, I guess. So maybe I shouldn't worry about that for now. But this number, I don't see why that's coming into the thing at all. The line should be X, Y. Okay, that one might be okay. It's the row number. But the connector, no, I don't know. Really, that top line is length. Yeah, it's drawing the line in row 0, but it shouldn't. It should be drawing it somewhere else. I don't know. We may be gathering some of the wrong information. Okay. That's annoying. All right. Now, to your previous thing, can we get a cluster? 2 leaves at higher rows, 5 and 6, to make sure it works at non-zero. Yeah, so I think this test is actually the simplest one that can do that. Because if we just have 2 clusters, there's nothing that would force the third cluster. I mean, this one is going to be right because his predecessor, his starting point on the first child is 0. And that's always this case. So if I left off starting row plus, it's 0 plus anyway, so it doesn't matter. But this one down here does. Okay. Only leaves should be getting their centers from the rows. Yes, that's a true thing. Now maybe she's in supervised clusters. The leaf should know its center. Oh boy. All right. Okay. I think. All right. Yeah. Yeah, I mean, it is kind of recursive because we're looking at the children first, and then once we have them, we get that. All right, I'm sorry, excuse me. I got to take a couple-minute break here. Be right back. All right, excuse me. Welcome back. Yes, think of singular as recursive. Its value has been pre-calculated. Yeah, I think that makes sense to me. I think what's not so good, it's like our cluster still doesn't have our connector. I don't think it still has enough information to draw the stuff. Okay, the center is nice. Well, okay, the center is where we're going to put the button eventually, right? So if I go back to this, I'd like to have a button or at least a sensitive point here and maybe a toggle or something. But I want something here at the middle of this line. And so that does tell me where to do that. But I guess I have to look at I have to draw this line from the center of the one to the center of the other. The question is, where do I draw elements? Well, maybe it is enough. The element center is the row number. Okay. That's fine. So when I'm drawing a cluster, I'm going to, well, maybe I'm just leaving out the connectors. I think, okay, I'm going to tentatively say that this is okay. I guess let's look it over. There's something redundant here because these two are very similar. Okay, so we get the connector for the starting row, connectors, okay, because it may be a whole tree of stuff. And then we add in the connectors from the second child, so first child, second child, and then we add in our connector. But I think we've said the first child, okay, let's see these centers. Gosh, they're just so similar. I mean, center from a starting row. No, I'm convinced it is. I may be wrong, because if you're coming into a cluster here, you need to start this one down here. You know, you can't just say this one starts at 0 because it's the leaf. of a cluster. The cluster itself has to start on a particular line, and I think that's always going to be a function of how many children are included in the range of that cluster. So the V cluster here has 4 items. We really want to draw this line at row 5, and I think there's no way around that one, that we have to know the row, because otherwise we would have we don't have a notion of which row number it is, and we know we need that for this kind of thing. If we were trying to like plot them in space, like on a plane, and put close ones close and far ones far, you might not need that information quite the same. But I think, okay, cluster takes C1, C2, both have a center value. Yeah, so for the current cluster, those values would be their rows. Yeah, I think maybe that's what's missing, is maybe we need a connector. Well, yeah, if C1's a cluster, the center would be calculated. Well, no, the center. So wait, C1 and C2 past and previously. Well, I guess it depends which way you're thinking of the recursion going. Maybe I'm assuming we come in at the top level, and we're given, we are a cluster, so we're coming in at the top level cluster, R in this case, because the cluster's being pre-computed. We did that much. So coming into R, and we're saying, as far as you know, the first element should be placed in row 0. Okay. And so it says, okay, well, how am I going to calculate my center? Well, I'm going to recursively, well, we've already pre-calculated. No, we haven't pre-calculated it. I'm going to ask my child what their centers are. Okay. And then I'm going to ask them for their connectors and build up the list of connectors. So, my center is a function of my children's center, a sort of direct average of those. That part feels good. Okay. What I wonder is maybe missing. I think maybe like how we're drawing the lines. It feels like because we don't have a connector for this, we're trusting the parent to draw the lines for it. And I think that may be a bad way to do it. I don't know. The cluster. Okay. I guess one thing I wonder is, should element be returning some sort of connector, and that connector is prepared to just be a one row thing? Connector, top line, bottom line, center. I almost think like, see, center. Like, yeah, to your point, if the row kept the leaf has the row as the center, okay, then we should be drawing. It's almost like we need a height, If I knew my height was 0, yeah, that's correct. Element A is centered at 0, B at 1, and that's what will happen in here, okay. Because when you ask for the center of an element, it just gives you the row number. Okay, so yeah, there's row number returned back. When you ask for the center of a cluster, now I don't know if this is right. I mean, I think maybe this formula that we're using down here, right? Average the two centers, I think you could argue should be up here as well, or maybe instead. The center from a group of things starting at row number. Well, I don't know. This use the center of the first cluster, another cluster element takes the midpoint. Right. Um, I think I don't know, top line, bottom line. I I wish we were sitting next to each other. We could draw pictures and get through this easier, I think. But I think maybe this connector is a stupid idea. Not stupid, but I don't think it's quite right. I mean, we want a cluster to draw itself. And so I think maybe a cluster should just be drawing this vertical line. Like should the element be drawing this? But the distance is 0. Distance to itself is 0, right? I think that's got to be true. Yeah, I mean, like in this table, 0 to itself. So if the element drew his own leg, he would draw nothing. Okay, so I guess the clustering is determining this length because it's the distance from A to B is this distance here. So we can't draw anything for the element. There is nothing to draw because it would just get a point and we wouldn't even see it. Okay, so I guess I don't feel as bad about it, connector then. But where is it drawing? That seems like something connectors should be telling you. Oh, sorry. Top line should be the midpoint of C1. Yes. Yeah, so I think when you draw your children, when you draw a cluster, you're going to ask, yeah, we should be starting from the center of the first child to the center of the second child, only left of it, because, based on the distance, based on our level. And we're not doing that because something's going wrong between, okay, maybe we are on the shape. I think the clustering maybe isn't. I mean, I think there's something off that I'm having to recalculate starting row plus elements and all that stuff. But I think, on the other hand, I believe it's more or less correct. The drawing is definitely screwed up. Okay, because we're telling it number. That's the row number, and the connector has no connection to that row number per se. He doesn't know it. So what the heck? So the element rows, well, a connector, the U shape is always going to connect. A U shape going to a leaf is always going to be exactly in the center of that line. So a B, C, D, E. They're all in the center of their line. All right, so that seems okay. What does he need to know? I mean, he needs to know, maybe that information has got to be in here. Like, he needs to know the starting row number. No, that shouldn't be right. He needs to know the center of the element. The center of A. Let's make sure that's true. Center of A. Center of an element should be itself. And I think we saw that. Yeah, so we given a row, the center of an element in that row is itself. Okay, so that I don't know. So this U-shaped thing is really the heart of it. All right, so he's got the frame width so he can figure out how to draw it. That's fine. He's got the connector. I don't think this number should be coming in. I don't think he should need it. Everything he needs to know should be in the connector. And notice we're not doing center anything with center here, so that's a bad sign. All right, but C1, it's like clusters don't use the center of the elements. Are you saying the connector doesn't, or? Well, the other thing I know is going to have to go in here at some point is the cluster itself, because we need to know like all your children and stuff like that for the selector when we put the button in. I'm building the tree using C1 and C2. Okay. The clusters don't use the center of the elements. Well, they do. If this is a leaf, his center is the same as his row number. Okay, so for either of these cases, if they are, a leaf computes its center by just returning its row number. The cluster will be this average of them and not there. So I think it is using the center because it will get the row number center if it is. Starting row comes basically if you're coming in at the top, the root element of the cluster, the farthest left element, that we know its first descendant is going to be in row 0 of the cluster. So the root, its first, its starting row of the whole tree is got to be row 0. And then, kind of repeating that for sub rows. Okay. I guess my concern is I don't think I have enough information in a connector. Like, how does Topline know where to draw? Okay. It gets drawn based on number. Okay, but that's not right. And the way this one's working is it's running through connectors and it's assuming row number is the right place to draw the start of each connector, and that's why we're getting a goofy shape. We're getting unconnected stuff, disconnected stuff, because in our tree we were supposed to draw this line here at 1 because we had 1 and 2 connected. So I think if you move these two lines down and then move this one up, or vice versa, I think you would get the right tree out of it. Okay, is that cluster preceded by element only? Well, Starting row should be used by the element. Yeah, in the cluster, it's only indirect. A cluster, I mean, its children may be elements, but it is not. So, yeah, it doesn't. It doesn't need. It doesn't need that. Now maybe. No, we don't know the height. Okay. I don't know. Again, I worry connector was maybe too clever or something. Or actually, I think it's too impoverished, is what it is. But I didn't want to put this information in cluster, because clusters, the clustering should be independent of the drawing. At least I'm pretty sure of that, because we could have chosen a different way to draw our clusters. All right. So I guess the question would be, like, how do I know when I draw a line for, well, here's line. Okay. Sorry. Line doesn't use number. Nobody uses number but U shape. Okay. So when I'm in a cluster and I say, I've got a connector and I want you to draw a line, 3 lines, 2 horizontal and 1 vertical. The vertical one, we know, well, we know its height. Y scale, that's not right. C1 spinner, yes, I believe that's right. Yeah, those need to come off there, and I think we never had that enough information in the connector to draw that correctly. So I think you need to know. Okay, so the center is saying, well, what's it? Center is saying, where's this bubble going to be? Where's the button going to be? And we know we have the right position. I mean, we believe we have the right position vertically. This is 0, 1, so this is at 1/2. And that's the center. But we don't know how far up to draw, like how big to make this vertical line. It's 1 line's worth here, but it's 3 lines worth, no, 2.5 here. Okay. Like, okay. So I don't think we can't derive that from the line number. So the line number should be irrelevant to the process we're in. And so that's why I'm very convinced we don't have enough information to draw it correctly. Now, what I think you're saying, top line is draw at the Y position of C1 center. I guess if connector knew the center for C1, I guess the connector knew the Y position for C1 and C2. It's got the position and the length, and it conceptually draws from the right to the left. Yeah, the cluster, well, again, I'm going to, I think, I don't know how to, I think what I've done is I've blended stuff. The cluster has added stuff that's for the benefit of the drawing. This is an example. I really think this should not, even though all the calculation is on row number and elements and stuff it's either arguments or parts of the collection. I don't think it's a valid question for a collection a cluster per se. Okay. That's the fact of the value of that is useful because it's used for dendrograms. It's not used by the cluster in the sense that we did distances and grouped them and all that stuff. So it can tell you the center based on children. Yeah, I think I keep going back to what you're saying, of center calculating it directly. That's the true thing that's got to happen. And we did that up here or down here. That calculation is okay, and it's used down here. but I think the the connector has to be the one to draw the U shape, because an element doesn't know how long to make that bar. That's a property of the relationship between it and the next thing in the cluster. So I think the top line, I'm going to change this name and start down this path. Okay, so top line should be top line length. Okay, and then bottom line is bottom line length. And I suspect my test did not get redone. I know we had this named before. Okay, top line length. I'll probably push my lines too long and get more yellow dots. Okay, and then bottom line length. Okay, let's see if that. Okay, now I think I think you need to say, I think you need to tell it the top line's starting point. Connector has a cluster, but the center of the cluster shows. Yeah, it doesn't know the cluster right now, so it can't in that sense. But maybe that would be better. I mean, if you had the cluster, right, then yes, it could ask child one, what's your center? Well, that's not quite true. No, I don't know if he can get that or not. If the center, he can't get it from the cluster without the row number being involved. Because every element only has a center based on the row it's in. So I don't think we can ask, if we ask the cluster the center of child one, we have to tell it what row we're starting from, and I don't think we'll have that information. Now, you could. I mean, if I kept track of the Y top, I mean, what if I stored the two centers in there? Okay. So center in the cluster. Yeah. I know I'm being very resistant on it. And again, I think it's because the cluster and all that algorithm we did around the cluster, it really has nothing to do with row numbers and dendrograms. And so I don't think the cluster should know that, because that is really, if you decided to draw it as a dendrogram, what's the center given the row number? And that question just feels very like unrelated to the clustering, which is like, what are you closest to and what's your distance and all that kind of stuff. So I I don't know. I think to get yeah, exactly. I think if I put it in the connector, I don't know if that's going to be terrible, but if I said the connector, I'm going to tell you the top line. It's not really. It's kind of the y-axis, I guess. Let let's see what happens. Okay, I'm going to say top line position. I hate to call it y because it's in a it's in the domain where this is 0, 1, 2, 3. You know, it's not really the y-axis per se. Maybe it is. Maybe that's okay. Let's try top line y, bottom top line length. This bottom line. I copied the wrong thing somewhere. Bottom line y. Okay, if I had those things, then center is almost. I mean, it's redundant almost. I mean, the center is going to be, you know, it's top line y plus bottom line y divided by 2. Okay, so I think that can be that if that were there. It's not there yet. Okay. Okay, so I'm saying I could put these things in my connectors. Yeah, so it's going to be responsible to fill those in here. Okay, so it's going to say top line y is C center 1, bottom line y is center 2. I can get these in the order that makes sense to me. Okay. And I think, well, I just broke a bunch of tests too. This thing needs to know. Let's put top line y. I'm going to say minus 42. And then bottom line y. 43. Okay. And then all the people who tested this thing, okay. A bunch of people who tested are going to be complaining that they don't have the right stuff. Okay. So bottom line, well, top line y. Oh. And I don't know, this is becoming a pain to write. Top line y. Okay. This is connector 4, C1, C2, so 0 and then 1. Top line y is 0. Bottom line y is 1. Top line y. Okay, so that's sorry, C1, C2. So the halfway between them is 1/2. And then bottom line y is 2. Okay, so these two went 0 to 1, 2, and then he connects those, and his center is somewhere between the top line and the bottom line. Okay, line long. Yeah, we'll work on names and stuff like that. Okay. Yeah, we probably need. Yeah, yeah, we'll get there. Let me add that so I don't forget again. Okay. Tests. Okay. Oh, he didn't offer to insert it. Too bad. Top line Y. This clusters 2 and 3. Connector 4 clusters 2 and 3. So 0, 1, 2 is 1 is 1. No. Yeah, 1. Bottom line Y is 2. And then here, I don't know why I need the ID either, come to that. But anyway, top line Y on C1 is 0. And bottom line Y should be 1.5. No, not 1.5. Is it 1.5? Okay, so it's 1 and 2 clustered together. Killing myself with these names. 1 and 2 clustered together. Okay. Their average is 1.5. Okay, that's this one. Then 1 and 4. Okay, top line should be 0. Bottom line is this one's center. 1.5. Okay, it is. Okay. This is tedious too. Okay. Top line Y. Connector ID 7. Okay, his Y is 0. One. Okay. Connector 8. 0, 1, 2, 3. Top line is 2, bottom line is 3. Okay, connector 9. 0, 1, 2, 3, 4, 5. Okay, now they get complicated. 10 connects C2 and C3. So his top line should be C2's center. And his bottom line should be C3's center. 2.5, 3.5. Okay, that seems right. And then finally 11 is clustering C1. Okay, so C1 center is 0.5. And C4 and C4's center is 3.5. Okay. Center 2. So 3 minus, sorry, 3.5 minus 0.5 is 1, is 3, divided by 2 is 1.5, plus this half is 2. I think that sounds right. Okay, any more? One more. Okay, he is clustering C1. Okay, that's an easy one. 0. His bottom line y is 1. His center is 1/2. Okay. A lot of long lines. All right. These should all fail because we don't calculate those top lines yet. And we'll do them all at once. Okay, 10 failures. Good. All right. So top line y, we said is center 1. Bottom line y is center 2. Now we find out how good my math is. All right. I call that progress. All right. So add top line y, bottom line y to connector. Okay. Now this center relationship, that should always be true. I think we can say that okay, that's that. So anybody who writes center is going to be wrong. All right, so we won't put center in. And I'll be explicit on the type here. Okay. And then these tests can take that out. I keep subtracting instead of adding. Oh, golly. Center. Okay. That should still all pass. Okay. Make center calculate on the fly. Okay. Now, do we have enough to draw our stuff? And if we do, then let's go back and build this line abstraction. So dendrogram, now when you draw, okay. Okay, so top line length, the position here vertically should be connector.topline_y. All right. And then the position here is connector.bottomline_y because it's the bottom line we're drawing. All right. And then back to earlier discussion, this thing should be drawing from here to here. Okay. So it's it's, I guess the distance is going to be bottom line minus top line. Minus connector dot top line. Okay, because we want however far apart they are should be the distance we draw. But the number here, x, y, that should be connector dot center. Is that right? X, no, center's a y coordinate. Is that, oh, this is y. Top line y. Yes. What connector dot? Okay, so we're drawing from the x coordinate as far over as we decided to draw it, and start the top line y and draw it the distance to the bottom line y. This is where this delta thing is not as helpful. Okay, and now I don't think number is being used in here, right? Okay, so number, number is not being passed in now, or not being used. We don't have to pass it in. I want to run it first, see if we got anything resembling what we expect. Okay. And my done is not centered, so something has really gotten odd there. Okay. Did it? I wonder if the scale is way off. Okay, but we do still have these. I don't know if that's helpful. 4436, 44809. It's trying the same one twice again. 4437. That's just not quite right. Okay, I think we can. 1 minus connector to level. Okay, that is probably okay. I think we're in the section above, so we can print stuff. Top line y is top line y. ID is connector dot sequence number. Top line length, bottom line y. Connector. What does he have, an ID? He had something. Okay, ID. Okay, so I think that would tell us, and let's put a new line. All right. I'm going to run that again. Surface should be drawn as circle. Yeah, that's definitely right. Okay. ID4, top line 1, 5. Okay, these are the unscaled numbers. 1, top line length 1/2. Bottom line 2, bottom line length 1/2. Okay, that seems right to me. Okay, now does that mean these are? And then it drew line 404. Oh, then it drew 3 lines. Okay, 404.36 to 809.36. This is X. So at position 36, 404 to 809. Okay, about halfway. All right, then 404.72, 1 line further to 809.72. That seems right. Then 404.36 to 37 seems wrong. He's got to be scaled somewhere. That's going to be Y scale times that. Bottom. That uses Y scale. That uses Y scale. Distance should be in the X direction. The X should be the same for both of them. And this distance, it's saying it was doing line numbers, 36 to 37. Yeah, I think it was just adding 1 because they're 1 apart, 1 row apart, but it should be a factor of, 36. Okay. I wish I had a cheap way to round those two, but hey, that sort of seems like something. Okay, let's go look and see what our data is because I have no recollection of where we left that. C2, C3, okay. C1, C4. Yeah, there's C2, C3, C1. Well, yeah. It looks right. Yay. Okay, so now that makes me want to do this one because it was the big ugly one. That line can go. Okay. Let's see if this looks right. Oh, that's nice. Okay. And it has, 7 and 8, or 1 and 2, 7 and 8, 10 and 11 are all equally far apart. They're both clusters of 1. This cluster, the closest to 8 to 10 is a distance of 2, is closer than 2 to 7. So this one gets clustered like this, and then that one gets clustered like that. Okay. Oh, my. Now, I don't know why done is not centered, and I'm not that worried at this point. That is nice. Those buttons don't have a lot of room. So basically the button has sort of 1 line length to squeeze in. That makes me... Well, I see more things to tweak. Okay, I think I did 85%. I think I would be better off maybe like 75%. Give 3/4 of the screen to these dendrogram lines, and then a little more to this. I wonder if we made these bigger vertically. Like if I made it line spacing of 2 instead of 1.5, let's just see how that looks. It's more problematic when we get 40 or 100 of these things, but I think we gotta make sure we can fit a button in where we want buttons on those intersections. All right, that's nice, and nothing else got wonky, so it seems like we've been doing our multiplications and stuff correctly. Okay. Oh, it feels good to have this in place. All right. So, I mean, what I hope to get out of this, I think we can get. That's great. Let's clean up some things. Okay. I don't think we need the simple examples at this point. We're not going to go back to them. Anything, we're going to go start figuring out how to get tunes in there. All right. So that's commented. I'm going to be optimistic and delete this however many times I put it in and out. But okay, now this Y scale, all these are. Okay, I guess that's okay. Okay. Oh, excuse me, just a minute. All right. I mentioned my daughter was pregnant and about to give birth, and apparently she has now. So we're due for a break anyway. Let's take a 5-minute break. I'll see what's up on my end here, and we'll come back and I think add that line and see what we can straighten out in the cluster. All right. So thanks. I'll see you in about 5 minutes. All right, welcome back. Okay. Well, I do in fact have a new granddaughter, so woohoo. Alrighty, let's deal with this line notion. And I think, thanks. All right, so we want to combine these two into a common thing. And let's make a line. I think this will be enough. Line. I don't know if that word is used, but we'll take it. Okay. And then maybe it's almost more like a vector. Well, they're horizontal. No, they're. I mean, it's not grounded on the x-axis, but it is grounded on the y-axis. Like, jeez. We don't know the x. Well, where's the dendrogram getting x? It's the level, right? It's such a weird dimension we're putting on this thing. U shape. Okay, x is 1 minus connector level. 1 minus is because it's sort of drawing from the right-hand side of the screen. Well, let's let y of double length of double is that useful? Is it a point? I don't think it's a point. It's really like, well, I mean, it definitely has a length, so I don't think it's a point. But it's sort of unconstrained horizontally, but constrained vertically. So it's a weird little thing. It's almost. It's not a line yet. It's more. But could we calculate? Could we give it the line stuff? We might be able to. Right. Well, the level. I don't know. Okay. The level is almost the line length. Well, no, the line length is for clusters. They are shorter. So it's not all the way across. Yeah. I I I gotta find a better word. Line leg. Yeah, let's try that. Okay. All right. So public var top leg of type leg. Now top line y length should go into that. Okay, so anybody who does that, I think the compiler will talk us through this refactoring. Okay. Top line y. So this is top leg is leg of y is center 1 and length is this. And a million tests. Whoops. Comma. Connector. Well, leg is hashable and equatable. Well, I wish I knew what the problem was. Top link, dot link, top link. Connector dot top link dot length. Connector dot top link. Oh, line dot length. Okay. Field expression. That doesn't seem like a problem. Ugh. No exact references in static. That's such a bad message. Is there one more top line? Oh, you're right. Thank you. Top leg dot y. All right, and then the other leg. And a bunch of tests that we already looked at. Missing one. Left, 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 right. Oh, assert. A little tedious. And are you still long lines? I don't. I guess I can do this. Probably all like that. I don't know that the ID is going to add anything. Oops. Not sure what that's all about. Okay, let's see where we are. Yeah. No, I think leg's a good name. All right. Use leg. Okay. Oh dear. Still have. Okay. Well, I'm glad to be here by the end of the week. Okay. I think let's go back to a dendrogram view and figure out what. Okay, he's not centered because we did this. I'm not sure we need that in the end with what we did with this double frame thing. Yeah. Okay. I'm just going to tweak this. Yeah. Okay. I think, we probably have time to put our button in over top of this thing. I know I've seen something to draw a circular button in Swift. Otherwise, we can put a circle in and annoying amount of work. I don't know. Maybe I might just try putting a circle in and see what I get. I don't know if I can center it like that. Dendrogram view. Okay. I'm going to take this out too. Oh, we said we didn't need this number. Okay, so I've tweaked spacing and constants. Now let's get number out of here. U shape, we don't need number. That's nicer. Okay. Oh, okay. So now the enumerated, I think we can just do this. I don't know if we need the element. We don't need the number anymore. Build that. I think maybe this doesn't need to be here because our elements are identified. I guess the sequence number gave us that, so that's the reason we have ID in there. Okay, yeah. Yep, good. Okay. Okay, so I guess the question is, this is almost a cluster. I don't know if I call it cluster, if I'll mess things up. Give it a more semantic name here. Okay, and then what I want to do is I want to put a button in, or maybe just a circle. Circle. Okay. Okay, well, frame we can do. Stroke. And I guess our frame size is Y scale. It's a function of Y scale, how far apart two lines are. I guess let's just take 3/4 of that. It's just color. Black I'll do for now. And I need to do some positioning. That. Offset. Yeah. I'm forgetting the name. We sort of had it at one point. Oh, dot position. Okay. X is X, Y is connector dot center. And that's going to be, we're going to have to adjust that by half. Okay. What have I done this time? No. Why should it complain about that? Content. Y scale. Okay. Color. Oh. Y is connector. Yeah. Dot center. Oh, come on. Something about is group the wrong thing? I don't see why. Hidden no member stroke. Circle has no member stroke. I thought we just saw an example right here. Well, I'm not that attached to it, I guess. Something ought to happen. Okay, well, that's something. That looks like 2. It's like my Y is not correct. Connector center is Y, yeah. Correct X. Oh, do we have to scale it? No? Oh, did we scale Y? I gotta scale Y. Yeah. Oh, okay. That's the, I think it's the highlight color or something, but it's the default color for this screen anyway. I think a touch smaller might look nicer, but yeah, this is getting there. I'll try half. And I guess the X and Y is the center, so that worked out nice. They look centered to me anyway. Yeah, that's good. Now, really, these should be. Well, I don't know. Something. So my notion is that you're going to click on some node to select the things you want. So this is a kind of a filter. Yeah, white with green outline. Yeah. No. Foreground color. White. And then. Well, maybe stroke only applies if you had the foreground there in the first place. Yeah, not available. And maybe this example just is not the way it works anymore. I don't know. Fill color padding. Yeah, that's. No. Let's see if we just cover stuff up or if it already keeps some sort of order. No. How odd. Oh, I guess I'm drawing the line after because it was green before it knew. Yeah. In principle, we probably should chop these off by half a tick there. Yeah. Yeah, I guess we could draw them after the diagram. I mean, I certainly could draw this, one half a line length shorter. I'm gonna, yeah. Yeah, I mean, I don't know if we can. This is. Okay, I think the problem is I draw one of these and I draw the circle, but then I come in later and draw the next one. The next level up is going to draw its first line all the way that top leg length. Well, that intersects the circle. So I don't know if this adjustment is. And actually, I wouldn't mind a little more white space here if it I was thinking about how to adjust for that, but maybe this is the way to get it. If my length is minus, If I do that, I think I'm allowing the circle size there. Well, I guess it's the circle is the width is half of Y scale, so half that width is a quarter of Y scale. I'm always good at justifying. Yeah. Okay, well that's tolerable enough. I don't know if like I'm not sure from a UI perspective what I want this to be, but the idea I have is that you're going to come in here and you're going to select, like maybe you would click here to select it, and when you finish, I mean basically what you're saying is I only want to pass through these two items, this cluster, or you could take this cluster and get these four. And so I'm kind of not clear what UI would be right for that. If I did check marks, it's a little weird that you check this and then all these should kind of come. And maybe these should be doing something, the leaves that are actually included in this thing. That would be kind of nice. But this is either, maybe I go to boxes and do check boxes or something, but I want an interaction that's click on this, these two light up. Click on this, everybody lights up. Click on this, these three light up. Click on this, back to these two. And yeah, maybe this goes bold when they're actually selected. But something to get the cluster. Oh, we got stroke border. Border chart symbol shape. Not used in this context. Let's look at Apple's documentation. Maybe they'll have, I don't know, usually they leave all that view stuff. Yeah. Shapes. View styles. Okay. Whoops. Maybe I just need to do color and no, I shouldn't need to do style. Border? Maybe let's try border. Do I have to say width? Okay, well, like I said, maybe I want checkboxes anyway. Yeah, that's not going to do it. Yeah, that's the way I was thinking. Like you overlaid a circle. Right. Okay, let's turn it into a button. I think that's maybe going to give us something. Okay, button. And put the action in here. Okay, so his position. Let me do this. Was a checkbox. Just to get something going. Okay, and then overlay. Oops. The button around with corner radius. Yeah, that probably would work. I'll just do that for now. All right, so I don't need the circle. Maybe I need the frame. Let's see how this looks. Ugh. Button action text. Do I have to put a label in there? No. Action, that stuff, that text. Let's take this stuff off for a moment. Well, this is probably the one I care about. Doesn't like corner radius there. But, well, I mean, I know we can do overlay, but I thought, that's not switch UI. Dedicated modifier, yeah. Well, it seems to like it. Okay. I don't know if it'll be centered properly. Oh, he's sort of okay. This one's on. Oh, first button on the page is by default. Now, the scale of it is a little wrong. This should be a function of Y scale, I think. Yeah, closer. And his size is not good. Well, we did that up there, right? Where's the font? I can imagine a better looking check mark. Well, that's just not right. I don't know, these adjustment factors are getting out of hand. Go. And I'm still not getting it right. I mean, he's only half the size, so yeah, I think it is still too big. Okay. And we can put, at some point I can look up this color. It does look a little small to me now. But I don't know if maybe you only check the one you care about. That should turn off anybody else and check you. I don't know if you should get your descendants checked automatically, but the leaves ought to be like bold or something, the ones that are selected. Okay. All right. So whoops, where's hello? Oh, click a button. Okay. Alrighty. Let's see. I'm. I think we'll stop here. The next stage I see. Okay, I haven't done anything on my to do. Determine the center of each connector. Satisfy connector with a leg object. Draw the cluster diagrams. Draw the nodes. That's all good. Okay, this is all part of clustering. All right, but now, well, we need to activate those buttons. I'm thinking bold, but we may change our mind. And then we need to cluster or feed in the cluster the tunes, not a hard coded tree. And then we have to make this thing, we want to filter. Make the selected nodes pass through the filter. Okay. And I haven't done that before. We had the selection, the view, that's the only one that does it. Filter does it right in line. Quantize does it right in line. So cluster's the first transformation that has a notion of being a two-part thing, and maybe it shouldn't. Maybe it should just, you want to cluster it, you show the cluster and do that. So whatever the mechanism is, we'll show the cluster either with this and done or something, but it's going to filter just like the filter itself does. Okay, so I think what I see, I imagine that's going to take at least 2, maybe 3 sessions, depending. But I think we will wrap this part up next week, I hope. So next week is going to be Monday through Thursday, I think. 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC. Thanks for joining. Mudshark, thanks for all your help, of course. And hope I can see you and others back next time. Take care. Bye-bye. Have a good weekend.